Today we're going to present the chemometric analysis of heavy metal pollution in the Yamuna River in India. So here is the introduction. Because of the rapid urbanization, industrialization, the population growth, it leads to heavy metal increasing in wastewater and flowing into the river. So heavy metal in low concentrations are very important, but it's very toxic while the concentration is high. So then we have a method to evaluate the current heavy metal based on the base water quality using some of the chemometric method like HPI, MQI, and other index. Um, so here is the basic steps of the experiment. We're going to pick samples from five pollution sites, A1 to A5, along the river from two different times, the summer and the post-rainy seasons. And then we have the pre-treatment of the water sample, and then we're going to measure the concentration using the atomic absorption spectrometry and acid digestion procedure. And all the results are going to be expressed as the mean. Here we have a few equations for to help to calculate the result. The HPI shows the overall quality of water with respect to contents of heavy metals. So the critical value is 100. If we break down the formula, we can have a few parameters like the WI and the SI. So here is the explanation. Then we have the MQI, which is metal quality index. So this represents the threshold warning, the concentration. And here there's the result and discussion. So from the first picture, we have the means and standard deviation from both seasons and for all five sites. So we can have a basic order of the heavy metals concentration. Then we're going to use the number to calculate the HPI. So here is the next one. We're going to get the SI and WI from the literature, and then we use the mean and standard deviation. We put in the formula. So here is the result of HPI of one side. So we have both lists set here, and we can see that A4 has highest HPI in both seasons, which means it's the most threatened by the heavy metal. And then this one is MQI, and it's said to be lower than 1 is good, but all of the samples have higher than 1, which is not good because it shows that it's seriously threatened by heavy metal pollution. So we jump to the conclusion. From the result and the data, we can have that A4 is the most highly polluted, mainly due to the discharge of foreign drain. And the HPI shows that the river along the river is unsafe for drinking in both summer and post-rainy seasons. MQI in all both seasons are indicating high metal pollution. So with this, I end my presentation. Thank you very much for listening.